for Gitte.
Thank you. Thank you very much. And this is going to be a bit of a gear shift compared to the previous speaker, but there will also be some overlap, I can promise you. So I've been putting together a little bit of everything from our most recent work, which mainly deals with neuroimaging. And I'll see if I can make it in time, or hopefully somebody can let me know. I don't have as many disclosures as Guy has, but what I'm going to talk to you about today is, first I'll just talk briefly about the classical psychedelics and subjective effects during the experience. You've already heard Guy say something about that this morning, and Chris. And then I'll move on to talk about the acute and long-term effects of classical psychedelics on the brain's serotonin 2A receptors. As you know, the classical psychedelics act by stimulating the 5-HT2A receptors. And how does it impact blood flow, vessel diameter, brain connectivity? And then I'll wrap up by talking about some of our most recent work on neuroplasticity, as you can measure it with molecular brain imaging. And then I'll get to the conclusions. And this is just to, you probably know this, but it's really about the mode of action on the pharmacological level. And as mentioned, the serotonergic psychedelics, also termed the classical psychedelics, they encompass compounds such as LSD, but also psilocybin and DMT. And what is interesting is that those different modes of pharmacological action also has an impact on the psychedelic experience in itself. And that is important because we know that a rating high on oceanic boundlessness, which are all the lower ones. I don't know if there's somewhere I can use a pointer, but anyway, I'll fix it without it. So rating high on oceanic boundlessness is also associated with a good treatment response in patients with major depressive disorders. And that also applies to healthy individuals. And for that reason, it becomes important also to look at healthy individuals because they have the same persisting positive effects as we see in patients with major depressive disorder. So in other words, they're a good model for our studies. So when we look at the mystical experiences questionnaires and we try to relate it to the positive outcome in a long-term perspective, when we ask 1 month later, in what way did the psychedelic experience impact your life when you look back? And generally, it is impacted very positively and associated with these different sub-items of the MEQ, with transcendence of time and space and ineffability being a little bit more difficult, but mysticality and positive mood certainly do. And here is the Roseman paper, which is one of the oldest papers, suggesting that patients that are responders also score high on the oceanic boundlessness and so forth. And that has been now supported also by the recent COMPASS trial. Now, when we talk about adverse events, it's important to look at the dosing effect. In this work from the Basel group, you can see that these different outcomes are dose-dependent, and they are comparable between psilocybin and LSD when you give doses that are comparable as well. And importantly, you can also see that as you increase the doses of LSD and psilocybin, you will also increase anxiety. And we just learned this morning that anxiety is not important for the outcome. So sometimes I encounter people who say, well, why do you want to get rid of the anxiety and the bad experiences? Because those are the ones that are helpful. I'm not so sure about that. That's not what the data from COMPASS has shown us. So how do you balance that between the dose and between different compounds? Well, the way we've done it traditionally is by looking with molecular neuroimaging at the brain's 5-HT2A receptors with the different compounds. And just to give you an idea about how that works, so you do first a baseline study. We use the tracer called SIMP36. It's a serotonin 2A agonist radiotracer. We also do MRI for structural information and some neuropsychological testing. Then we bring in the subjects and give them psilocybin, and then we start to take blood samples along with subjective ratings every 20 minutes. We wait for the plasma concentration to drop a little bit, and then we repeat the PET scan later in the day, so we can get 2 points from each individual, and then we have a conversation and questionnaires and follow-up as anyone else. And this generated this curve it's been a while ago we published this, but it has been very well cited, so I think it was well received by the field. And what you can see is as plasma psilocin concentration starts to increase, you will reach that expected saturation curve, and that allows you to determine a concentration where you will have 50% occupancy at the receptors. And you can also look at the occupancy in relation to the intensity rating, and as you can see, as long as you are below 25% of occupancy, there is really no psychedelic experience, but then as you start to have a higher occupancy, you have more and more of the intensity rating. You can also just look at plasma psilocin concentration and intensity, but that is a more noisy association. So you could see that we gave different doses to different individuals, but they each contributed to this curve. So it seems that it's pretty generic for the brain, how it's acting on the plasma concentration. Now, we have now repeated it. It turned out to be much more difficult and harder to do with LSD, but we managed to do the similar curve. Here you can see that LSD is much more potent. As you go up in concentration, you also have a saturation curve that is approaching the 100% occupancy. And the subjective intensity also takes kind of the same shape. We were also interested to know a little bit about the hysteresis effect. That is the effect that you see with LSD, that it takes a little bit to take on its effects. So we were asking the question, is that because we are having a delay in the occupancy? And that was a little bit hard to, I cannot answer that fully because we only managed to get 2 people back into the scanner to do that. So that was, it was a very difficult study to do. It was also in the PET-MR scanner, which doesn't make it any easier. But here you can see, interestingly, how at different doses, as the plasma concentration starts to increase, we have like a delay in the reported intensity, the subjective intensity of the rating. So we can confirm this, this subjective report that it takes a little bit longer for LSD to work. So there is not a direct association between plasma concentration and brain occupancy or the subjective intensity. And we think that has to do with the high affinity of LSD. It takes some time for it to find the pocket and to act. It also takes time for it to leave again. And that is what is causing this apparent delay in the effects. Now, way back in time when David Eritsu was a PhD student of mine, we were interested in MDMA, but as a sidetrack, David also found out that many of those who took MDMA, they were also psychedelic users. And he published back then that those who were 5-HT2A agonist users, they had lower serotonin 2A. So that made us ask whether, is this a downregulation that is going on, or is it a sort of a trait that makes you more likely to start using compounds? So for that reason, we started to look at the lasting effects of psilocybin on the serotonin 2A receptor. And here, again, the same thing. We did a 5-HT2A receptor scan at baseline. We repeated it after psilocybin. 1 week later, we did another PET scan, and then we did the questionnaires 3 months later. And in the sample that we looked at, and we stopped the data acquisition a little prematurely because we didn't really see much of a group difference between, so some went up, some went down. However, when we looked at the long-term effects, we could see that some aspects, such as openness, not surprisingly, went up in the patients. We could also see that the mindfulness was significantly increased after the psilocybin experience. And then when we looked at the change in 5-HT2 receptor, we could also see an association between the two, suggesting, but this is something we would like to replicate, suggesting that the more you can downregulate your serotonin 2A receptors, the more you will also have a benefit from some of the positive effects. And we've also seen that the brain serotonin 2A receptor binding is associated with the mystical effects of psilocybin. Again, something I like to see replicated in larger studies. Now let's move on to the fMRI. There's been much more data out there on what happens with the brain imaging with MR. It's really been a true journey. And this talented PhD student, now postdoc, Drummond McCulloch, he set out to do an overview, and he looked at, in the summer 22, he found that there were 42 articles that were based on 17 data sets. Most of them were actually based on the Cahart-Harris IV psilocybin study, which is nice because they were able to share it with many people, but it also gave a certain bias, obviously. So you're not supposed to read all of this, but basically what it did was to flesh out all the various ways that people had done these analyses. And soon we discovered that each different study or paper had their own way of analyzing the data, and that made it really hard to compare. So we reached out to all the authors, and luckily they were all happy to join that one single paper where we reviewed it, and everybody agreed that yes, it would be a good idea to standardize the way we do it. And later, when it was repeated in the autumn of 24, you can see there are more data sets coming up now, 7 more data sets. 80 articles seems to be a good thing that you can share these data, but it also gives rise to a lot of confusion in many ways, because things are not really done in the same way. Let me just talk a little bit about resting state connectivity with bold fMRI for those of you who are not familiar with how it works. Generally, imagine that every little neuron in your brain is talking. In some regions, you can capture these signals, and you can compare them to the signals that you can acquire in another brain region. And this is really building on the bold response, which is what you can capture with the MRI. And by means of that technology, you can assess how different brain regions speak together with each other. And there are such 7 canonical networks that are known or have been defined. There are also other networks, but these are the canonical ones. And you can then make such a connectivity matrix where you can look at how different parts of the brain speak to other parts of the brain. How coordinated is it? It's taken as a measure of how is the connectivity between regions. And here are the 7 canonical networks that we often talk about. And what happens during an acute psychedelic experience with psilocybin on the resting state functional connectivity is that you get an increased between network connectivity. So normally the executive control, for instance, is different from the default mode, but now under the influence of psilocybin, these networks start to connect much more closely. And here you can see what networks are particularly engaging more during the psychedelic experience. That also applies to DMT. And we also see an increased global connectivity. So if you take any given point in the brain and connected to any other given point in the brain, you also see a massive increase in how psilocybin is connecting different parts of the brain. And that has been ascribed as a fundamental thing that is going on during the psychedelic experience, that we see this widespread connectivity as a sign of the brain being much more interactive and creative in a certain sense, not bound by the usual networks. I will move on from here, but just leave you this one, because this is what the brain looks like when it's on psilocybin. So one of our favorite pictures. Now I'll move on to something called the entropic brain hypothesis. It's a term that has been used by many different people. And I think Robin Carhart-Harris was one of the first ones to coin the term in the relation to psychedelic drugs. And it's really a subjective quality of any given conscious state, and the richness of its content that can be indexed by the measure of the magnitude of what is called entropy. And for those of you who do not have a physics background, you can imagine that you can either be located in California, where we know what the weather is going to be like. I mean, it's going to be sunny 90% of the time, and there'll be a little bit of clouds sometimes, but not that much. So it's really very regular. We know it's very predictable, and it's done in the same way. Whereas if you live in Denmark, if you don't like the weather, just wait a few minutes, and you will like the weather again, because it's changing all the time. So you have a much more higher degree of entropy in Denmark than in California, weather-wise at least. Okay, so again, number of papers came out, different ways, the von Neumann entropy, again, entropy, all over the place. And what do we know now? Again, Drummond and a colleague of his, Anders Olsen, they started to look at that in more detail. So when we look at all the different papers, it turns out that they all have different ways of doing the analysis, and they do not really look at other ways. They have each their own way of doing it. And then, of course, the interesting question was, do they all converge to the same conclusion? I mean, these are different definitions of entropy, because the ways that data are analyzed are different ways of arriving at the results. So basically what they did was to compare all these different states, and unfortunately only a few of these different elaborate states were replicable in the same data set. So we used the same data set, a large data set, but the different definitions. So whenever you read something about brain entropy as measured with MRI, you should ask yourself the question, what kind of entropy are we talking about? So it sounds nice and good, but again, down to the methodology. And so let me just get on with this. And let's move on to resting state fMRI analysis again. So many choices. What kind of analysis do we want to do? I think I already showed this, that there was just so many options for how you can analyze this. And that brings me to one of our newest findings here, is where we've looked at cerebral blood flow with psilocybin, or rather on psilocin. Psilocin is the active metabolite that binds to serotonin 2A receptors and elicit the experience. And again, the Robin Carhart-Harris group were early on to explain that when you take psilocybin compared to placebo, your cerebral blood flow is decreased. And I know Amanda Felding was very disappointed to hear that, because she was expecting to see an increase. And I guess most of us intuitively would have thought that you would see an increase. We've also some data on cerebral metabolic rate, suggesting that metabolic rate is going up, so we would expect that to happen. But no, it seemed to be lower, and we have then later tried to replicate that. This is a study where we first do a pre-drug fMRI, then administer psilocybin, roughly 25 mg per person. Then we do the resting state fMRI at different stages, both at the ascent, the peak, and the descent of the psychedelic experience. This was done by our PhD student Christian Larsen here. And the way we assessed blood flow was using the P-Castle, which is a mode whereby you look at how, when you label the blood cells at the level of the neck, you can measure how it's transported across the brain as a measure of blood flow. And sure enough, we were able to replicate the finding. We do see a decrease in blood flow as the intensity of the experience goes on and as plasma psilocin levels are increasing. So we could replicate that with the MR-based methods, ASL. There is indeed, we indeed see a decrease. And we could also see that it was contingent on plasma psilocin. So the higher the plasma psilocin, the lower the cerebral blood flow. And that also applied to subjective drug intensity. So that's all good and replicable until we started wondering, well, wait a minute, the vessels in the brain also have 5-HT2A receptors, and they are constrictive. So could it be that we had a source of error by measuring something that had more to do with serotonin 2A receptors on the vessels being stimulated and contracting the vessels rather than a real phenomenon? So we made use of something called time of flight angiography, which you can pull out from the MR scans. Here you can see the transverse of the neck. The white dots are blood vessels, some of the major blood vessels to the brain. And you can extract those, and you can make a 3D reconstruction, which enables you to actually measure the diameter of the vessel at different stages during the psychedelic experience. And when we do so, we can see that the internal carotid artery, the major artery sitting here, that the diameter is going down. So it is constricting. So psilocin is having a constrictive effect on the cerebral vessels. And again, when we looked at the diameter and the psilocin concentration, we could see the inverse association exactly as we would expect. So is it really something that comes about by the central stimulation and the psychedelic experience, or is it just does it happen to be correlated with the psychedelic effects, because psilocin in the blood and subjective effects are also correlated? Okay, so if you keep that in mind for a moment, this is then again the same slide I showed before, a decrease over time, and then a gradual return to normal when plasma psilocin levels are lowered again. And what we actually found with LSD when we did our study, the same study with LSD, was interestingly an increase in blood flow. So how come that two compounds that presumably have the exact same pharmacological mode of action, they have different effects on the blood flow? That could have something to do with the vessels rather than the central 5-HT2A receptors. And when we look at the correlation between change in cerebral blood flow and the resting state functional connectivity that I just showed you before was increased, then interestingly, we find two complementary images of how psilocybin works on the brain and LSD, except that psilocybin reduces blood flow and LSD increases blood flow. And we have a lower functional connectivity when it comes to LSD. So what this shows you or tells you is that maybe the functional connectivity changes that we are looking at are more related to the fact that you see some vessel effects than it's related to what is really going on in the brain. It's a little dull, but that is what it looks like. So I'm going to make a little shift in gears here and move on to neuroplasticity. And the way that we think about how psychedelics work on neuroplasticity is that it stimulates 5-HT2A receptors, possibly TrkB, like BDNF, and it has a long range of neuroplastic effects. This has mostly been done in cell cultures, but it seems like an appealing hypothesis, because how would we otherwise think of it as a long-lasting effect? It has to be something that is really long-lasting. And for that reason, we've used another molecular imaging marker, which is UCPJ, looking at the synaptic density. And we again did a baseline. Another student of ours, Annette, did that. Did a psilocybin intervention with a profound psychedelic experience and repeated the imaging 1 week later, and also did the questionnaires. And again, we didn't see that much of a difference as we had expected. There was a trend, but not enough, until we realized that some of the individuals had been having their psychedelic experience in the MR scanner. And those of you who have been in an MR scanner know that it's not particularly interesting to be there. It's noisy, it's hot, and nobody likes it. It's much nicer to be in our room, our intervention room, with quiet music and so on. And we can also tell that when we look at the MEQ and the persisting effects, that those who are in the MR scanner don't seem to have such a nice experience. So when we looked at the presynaptic density, we could see that 1 week after, that those who were in the intervention room, they actually had an increase compared to those who were in the MR scanner. So, and there are some technical things that tells us that maybe we're even underestimating these effects. So just to get to the summary slide, I've shown you that the qualitative and quantitative aspects of the experience are important for the long-term effects. We already knew that. We heard that a couple of times today already. I think it's important to keep in mind. We see a high correlation between plasma psilocin, subjective intensity, the brain 5-HT2A receptor occupancy, but also to brain vessel diameter and cerebral blood flow and functional connectivity. The subjective intensity of the psychedelic experience is delayed relative to plasma LSD. So that's special for LSD. And contrary to psilocybin, LSD increases cerebral blood flow and functional connectivity is decreased. I also showed you that the psychedelic experience is sensitive to the session's environment, and that synaptic plasticity is enhanced by undergoing the intervention in a setting that facilitates positive emotional states. And with that, I'd just like to thank all the many, many people and students and participants and all of you for listening in. Thank you.